Hello students, today let us solve the problem related to the kinetic theory of gases. The question is given, 310 joule of heat is required to raise the temperature of 2 mole of an ideal gas at constant pressure from 25 degrees Celsius to 35 degrees Celsius. The amount of heat required to raise the temperature of the gas through the same range at constant volume is. 4 options are given. So this question appeared in CET 2007. See, before going to solve the question, now let us write down the given things. That is, what is given? 310 joule of heat is required to raise the temperature of 2 mole of an ideal gas at constant pressure. See, the heat capacity of the gas is amount of heat that is required to raise a certain amount of that gas by 1 degree. Okay. The heat required depends on the two factors at which the heat is added to the gas at the constant volume and constant pressure. Okay. On these two conditions, it depends. So, the heat required at constant pressure, that is given by Qp is equal to N into Cp into delta T. And the heat required at constant volume is given as Qv is equal to N into Cv into delta T, where N is the number of moles, delta T is a change in temperature, and you know that Cp and Cv is the heat capacity at constant pressure and volume respectively. Okay, so from the Mayer's law we have already discussed in our previous videos, that is, we know that Cp minus Cv is equal to R, where R is a universal gas constant. That is, R is equal to 8.31 joule per mole per Kelvin. Okay. So here what is given? 310 joule of heat is required to raise the temperature of 2 mole of an ideal gas at constant pressure. That is, Qp is given. Qp is equal to how much? That is 310 joule. N is also given, that is 2 mole. N is 2 mole. And temperature. What is the temperature difference? That is from 25 degree Celsius to 35 degree Celsius. So the delta T is 10 degree Celsius. Okay. So by substituting all these value in the first equation, then Qp, that is Qp is equal to N into Cp into delta T. Substitute, Qp is 310 is equal to 2 into Cp we don't know into 10. So I will rearrange this. Cp is equal to 310 by 2 into 10. So 2 ones are 2 15s are again 5. So Cp is equal to 15.5 joule per mole per Kelvin. Okay. So you got Cp value. Now it is very easy to calculate the Cv. Cv is equal to Cp minus R, that is 15.5 minus 8.31, that is 7.18 joule per mole per Kelvin. Okay. So now you got the Cv value. Here what you have to calculate? You have to calculate the amount of heat required to raise the temperature of the gas through the same range. Same range means delta T is same here at constant volume. Okay, heat required at constant volume means QV you have to calculate. We already know the equation for to calculate the QV, that is equation 2. QV is equal to N into Cv into delta T. QV is equal to N is 2 into Cv is 7.18, delta T is 10. So multiplying this, you will be going to get nearly 144 joule, which is the second option. That is 144 joule. This is how to solve this problem. Thank you.